Okay, and we have Andres with us.
Hey, Roberto, how are you?
Hey, how's it going?
Good, good. Just recovering from a long trip to Mexico.
Yeah, I heard that. Yeah, I was wondering where you were going to do the session from. I know that you're based in Europe, and Europe is quite late at the moment.
If I will still be in Switzerland, I think it will be close to 7 in the morning.
Yeah, well, it's not that bad. Wake up at 7 to do like a couple of sessions.
Yeah, that's right.
Yeah, anyway, welcome to the vJUG24, and thank you so much for the others for keeping with us on these 24-hour marathons. We almost at the end. This is going to be our 23rd session, so we have your session and one more, and then we're done. So we're happy that we're going to be able to finish without too much trouble. And before going into your session, let me just do a couple of introductions over here. So let me share my slides. Where did they go? Here we go. So yeah, so for this session, I'm going to have Andres making the most of your Gradle build. I'm really looking forward to hear this session. I'm mostly a Maven user, but I've used Gradle sometimes, so I like to hear what he has to offer me. And we're going to have IntelliJ to sponsor this session. So IntelliJ, if you probably heard about it, is a Java IDE, but it's much more than Java. It actually supports a couple of other languages. It's a polyglot IDE, so it supports Groovy, Scala, Kotlin, and a couple of other more. And regarding our session today, also has an awesome support for Gradle. And also Zero Turnarounds sponsoring this event. So thank you so much for Zero Turnaround to give Oleg, Simon, and Antoine time for them to run the vJUG and be able to organize these awesome events with us. So since, oh, sorry, I still have this one left. So if you guys already joined us, you're probably on Slack on the live sessions channel, but if you don't, please go to our website called vjug24.com. You'll find a Slack link over there. You're able to join the live session channel, and then you're able to communicate with us and post any questions that I'll be happy to relay to Andres. Andres is actually on the Slack channel as well, so you might be able to catch him up online and post some questions to him directly. I don't know if Andres minds about that, but I'm pretty sure he won't.
Yeah, no problem.
And we have our Twitter hashtag on vJUG24, so please feel free to tweet about us, and we're happy to retweet you. And make sure that you increase the video quality to HD quality, so you're able to pick up every detail of these awesome sessions that we're having. Okay, so now we're going to go to one more awesome session with Andres. So without further delay, I'll put the back to you. So you have 45 minutes for your session, and we hope that you have like 5 minutes left for QA. So please feel free to start whenever you want.
Okay, let me share the screen. And here we go. And let's change to the slides. So, well, thank you very much, Roberto, for the introduction, and Zero Turnaround, IntelliJ, and JetBrains, Simon, Oleg, and everybody else involved in this incredible event. I know that it's taxing for you to be 24 hours plus making this event, and everybody else joining the channel also. This is a huge marathon, but this is what we like to do. This is what we want to do, to share the knowledge. So the topic of today is making the most of your Gradle build, and what I have for you is a series of tips and hints on how you can make your build work a little bit better, so that you gain more speed, you get more behavior, you get more features, but still keeping your build files small and concise and expressive. In case that you have any questions, as Roberto said, please send them directly to the Slack channel, and or you can send them afterwards, after the session on the Slack channel as well, or you can follow me on Twitter or send me an email, and we can do a post follow-up. So I've been told that, well, this is the logo that you see right now. This is the logo that I like from Gradle, but this is the old logo. I should be using this one. This is the official logo. But what I really want to do is, when you guys are building projects with Gradle, I really want you to have fun. I really want you to be able to do whatever you need to do without having to worry on the build itself too much. Because what we care about is actually the production code and the test code, not so much about the build. So the 15 tips that we're going to see today should allow you to be faster and more productive with your Gradle builds. Now, let's get started with the first one, and that is, well, actually, I'm jumping ahead of myself. My name is Almiray. I'm a Java champion, coming from Mexico. Right now, I'm streaming from Mexico. I work for a Swiss company called Canoe. I think we were sponsors of last year's vJUG24. And I'm a member of the Groovy development team, and I'm also founder of the Griffon framework, which is a framework that allows you to build desktop applications. Now, in the past close to 15 years now, I come across with a lot of different projects, a lot of different builds, both commercial and open source. And since 7 years ago, I've been using Gradle in anger, a little bit of Maven as well. So that's this session is pretty much the culmination of the experiences I have had in the past, and figuring out how you can make your Gradle build work better. So the first tip is, how do you actually get Gradle installed in your system? And the answer is pretty much the same one as how do you get Maven installed on your system. Typically what you do, and by the way, if you don't know, if you know, but Maven just got the latest release posted yesterday, or was it today? This great Maven 3.5.2, and the next Gradle release is 4.3 RC2, if I'm not mistaken. 4.3 final will be released shortly. So when you go to the website of either of these projects, you locate a zip file, download it into your system, uncompress it on a directory that of your liking, then configure an environment variable so that you get the Maven binary or the Gradle binary on your path, and then execute the project and execute the build. Now, when a new version comes out, you have to do the same thing. Now, you will notice that this is a very repetitive process, and it's very likely that you could automate this thing. Now, I'm very happy to say that there are various options for you to download and configure either Maven or Gradle on your system. But the easiest way would be through the means of SDK-man. SDK-man, it stands for the SDK Manager. It is inspired by the Groovy Environment Manager and the Ruby Environment Manager. It's kind of like a package manager. Allows you to download different candidates on your system, Maven and Gradle being a couple of them, and it works on any POSIX environment. So if you're using Linux or any Unix variant, as a matter of fact, then you should be good to go. Just issue the first method, the first command that you see in the slide, and this will download the SDK-man script on your system. If you're using Windows, I suppose that if you're using Windows 10, you can use the bash integration and it should work. If not, then you can use either Cygwin or another shell called baboonshell.io, which is another repackage of Cygwin plus additional features such as Git and Z-shell integration and so many other interesting things. So anyway, once you get SDK-man installed on the system, then you can quickly go and install Gradle. Now, I already have Gradle installed, so I'm going to show it on the terminal. Hopefully, you're seeing the terminal right now. And I can ask for all versions of Gradle that I currently have installed on my system and are also available on the network. So let's see, this is a long list. And the ones that have an asterisk are those that I have locally installed on my system. You can see that actually the latest release available in SDK Man is 4.3 release candidate 3. And 4.2.1 is the Gradle version that I currently have installed on my system. So let's go. I don't want to update this thing for now. Let's go into a temporal directory, and I can call Gradle -- version. And this will tell me that it's definitely 4.2.1. If I want to switch to a different version of Gradle, say for example that I want to switch to Gradle 3.5, I can say SDK use Gradle 3.5 and do Gradle version again, and it says it's Gradle 3.5. Excellent. And when I switch to a different shell, so I'm going to add another tab here, and I can go to the same directory, or it could be something else. And now I do Gradle -- version on this place. And it tells me that it's Gradle 4.2.1. So the great advantage of SDK is that you can switch between versions and still be localized to a particular shell. So 4.2.1 right now is the default version. So as I start creating new shells, I will be using this version. But for the first shell that I'm using here, it will be only 3.5 until I decide to change this. You can install a different version of Gradle if you say something like SDK install Gradle, let's say 4.3 RC3. No, I'm not going to do it right now because we're streaming and this will download the binary, so it will take some time. But this is how you will typically install any particular version of Gradle. So once Gradle 4.3 is available, the only thing that you need to do is this, SDK install Gradle 4.3. Or if you're keen in not writing so much, SDK also supports aliases for all commands. So SDK I is installed, SDK U is used. You can list candidates and you can do more stuff with SDK. Let's see if I just simply say SDK H is with the help. And these are all the different commands that you have access to. Okay, so I said also, you can say SDK, you can install Maven if you want to with SDK list or L for Maven. And these are the currently versions that we have available in SDK. The latest version is 3.5.0 available from SDK Man, which is the one that I have. So this allows you to change versions very easily. And I certainly recommend you to have a look at the other candidates that are available from SDK. For example, a Spring Boot. You probably saw a session from Josh Long a couple of hours ago talking about Spring and Boot. So you can install it directly with SDK Man. Okay, the next one is initializing a Gradle project. And again, I'm going to refer to Maven because it's so popular and so many people are used to Maven. So starting a new project with Maven can be done in two ways. One is the copy and pray option. When you copy an existing POM file from another project, modify it, and hope that it works for the current project. Or you can use Maven archetype. Now, archetypes allow you to bootstrap your project in a certain way. They have a little bit of shortcomings, so we'll see that how to fix that in a moment. But for most of the times they work, and they allow you to start very easily. Now, I have good news and bad news regarding Gradle and archetypes. The good news is that it does not have any archetype support. Why do I say it's a good news? Because right now, when you try to search for a Maven archetype, there is a list of more than 100 archetypes in the default repository, and that's not counting whatever custom archetypes you may have in an organization. Now, also the bad news is that Gradle doesn't have any archetype support, so there is no way that you can bootstrap a project in so many different ways. But there is one command called Gradle init. With Gradle init, and there are a couple of variations, you can start a simple Java project or a simple Java-lib project. I believe you can also start a Groovy library and perhaps a Scala library. I'm not so much sure about Kotlin or any other JVM languages. So let me show you what I mean by this. Let's go again into the terminal. I'm going to create a directory called vJUG24. vJUG24 here. I'm going to show that it's empty. So now I do Gradle. Oh, remember this? There we're going to using Gradle 3.5. That should be fine. But in any case, let's use the latest version. So 4.1. Yeah. And now we do Gradle init. And after a few moments, now we get this structure. And this is the basic structure for a very, very simple Java-based project. We're going to see in a moment what the deal with the wrapper is. But the important thing is that we have a build.gradle file. This is your initial build for those people that are aware of Gradle. This is the same thing as Maven has with PalmXML. We got a settings.gradle file, which is also a Groovy script. And when we look at these files, they are almost empty, or at least all the contents of build.gradle are commented out, but at least they tell you, well, if you want to build a Java project, uncomment this out. You can have multiple repositories if needed. You can define as many dependencies using different configurations or scopes, and off you go. It's as easy as that. And you may be wondering, this is great for initializing a new project. What if I already have an existing project? And what if that project happens to be a multi-project build and happens to be a Maven build? Well, no problem. You can also call Gradle init on it, and it will generate all the matching build files for you. Now, you must be aware of one thing. This facility will only allow you to migrate dependencies, dependency definitions with the right scopes. It will not migrate any custom plugins that you may have applied on your build, because it's almost impossible, at least for this tool, to automatically match an existing Maven plugin to its corresponding Gradle plugin, because there may be more than one. So at the very least, you are able to get started with the basics, with the dependencies. But if you have any custom plugins, you must manually search for the corresponding or the matching Gradle plugin and do the customizations where needed be. There is one more thing that you can do. I'm going back to the slides. If we really wanted something like archetype support for Gradle, there is another project, there is another option that you can use. And this one is called LazyBones. LazyBones is archetypes with asteroids. You can also install it with SDK, as I'm showing right there, SDK installed. And once you have LazyBones installed, you have access to templates, or the templates will be like project archetypes. So let me show you what I mean by this. Let's go again into the TMP, and I do SDK list LazyBones to show you that I have the latest version, which should be 8.083. All right. So now, once I have this, I have access to the LazyBones command, and I can list all the different templates that I have access to. And it will tell me that I can create a simple Gradle plugin using this template, or I can create a Groovy app or an ASCII doctor documentation project. I can also have access to additional templates coming from different locations. So what I'm going to do right now is create a project that follows this template. Just going to copy that one and do LazyBones, create. The name of the template. If you happen to be offline, you have to give it the name, the value of the version, but in this case we are online, so that shouldn't be a problem. And then let's give it a name for this project. Now you would notice that it will ask me some questions, just exactly like Maven archetypes do. So I'm going to go with all the defaults. Just press and enter on all the questions. This particular project can be run with either Gradle or Maven. So that's another great thing about LazyBones, that it allows you to bootstrap any kind of project. It's not strictly tied to a specific build tool. So let's go into sample. And let's run Gradle. Yeah. If I say Gradle run, it will run the project. And there should be a simple window here on the screen. I can click this thing as many times as I want to. And if I do the same thing with Maven, in this particular project, I need to activate a profile, but all the configuration is taken for you. It does the compilation, and we should see the same window happening. So this project is happily built with either of the build tools. Now, what I like about Lazybones is, let me show you the contents of this project. This particular project has different artifacts that follow certain patterns. For example, there is a controller, so I can make it bigger. Or there happens to be a model. There it is. What if I want, I can modify these things to my hard content and change it to do whatever they need to do. But if I need to create a new controller or a new model, in the Maven world, we simply have to do copy and paste and modify all the things. But in Lazybones, we have another feature, what is called generators, which you may find in other build tools such as Geoman. So I can say something like this: Lazybones generates, and I know that my generator is packed in artifact, and I'm going to press enter. And this particular generator asks me, what kind of artifact do you want to create? Do you want to create a controller, functional specs, MVC group, services? Right now, I'm going to create an MVC group, which is a combination of model, view, controller templates plus tests. It remembers the package that I showed that used before. So I'm going to use that default. And now we ask me for a class name. I will give some names, for example, foo. And it says it has created about 7 different artifacts, 7 different files. When I go back into my project view, there is my foo controller. And it looks very much similar to the sample controller. And then I also got the foo model. So these have been initialized using a default template. So now I can create new artifacts based on certain responsibilities, based on the original templates. And there's no longer a problem of copying and pasting. It's making it easier to get started. Okay, so the third tip is fixing Gradle version to a particular release. And this has to do with assuring that your build is reproducible. There will be some teams for which the type of artifacts they build, they have the requirements to make sure that you can build exactly the same binary, given the same inputs at different points in time. So if, I know some people will say, well, as long as you're using the same JDK and the same OS version and the same machine, then your build file or the artifacts should be as reproducible as possible. True. If you're using Maven, it's almost unlikely that you can have a reproducible build across time. Because even if you fix all the plugin versions, that includes the clean plugin compile resources and the default plugins that we often don't see, but they are still there. Even if you do this, there is the chance that the root POM file that every single Maven project inherits from may be changed. It may be changed because it needs to be, and you have no control over these changes. So when that happens, your build will no longer be reproducible. So there's no way that you can actually make this fix. But in the case of Gradle, when you fix it to a specific version, you're fixing that locally. And even if there were to be something like a root pump, which doesn't in Gradle, you won't be affected. So how do we fix this? We use the Gradle wrapper. You remember when we called the Gradle init commands? I'm going back into the shell, going to change into the other project. Remember that we have the Gradle wrapper here. When we look inside the content of the Gradle wrapper's properties file, it says this important thing. It will download from the distribution URL a Gradle version 4.2.1-bin. So this will fix this current project to the version of Gradle 4.2.1. I can now change as many times my version. So let's go SDK use Gradle 3.5. My local Gradle version is 3.5. But when I run the Gradle wrapper and ask it which version it has, it should be 4.2.1. There we go. And if I didn't have 4.2.1 already installed as a wrapper, it would download it for me and then execute it. And this is a great feature when you're running Gradle builds on CI. You no longer need to ask the IT department to provision a specific version of Gradle for your project to work. Now, this is such a great feature that there is also a Maven wrapper project out there that you can use. Now, if you want, you can manually change the version of the wrapper when you edit this file. Or you can also, I believe there is a command something like Gradle wrapper, wrapper version, and then just give it some number, something like that. I'm not going to do it. There's another great thing about the wrapper is that it allows you to specify as a particular URL. Right now, we're using a public URL, but if you want to repackage Gradle with different dependencies, additional plugins, additional scripts, additional capabilities needed only for your organization, you can make it happen. You can publish it on a repository under the control, on a server under control of your organization, and make sure that your Gradle properties file points to that URL. Now, everybody inside your organization will be able to benefit from the custom version of Gradle. If you happen to be developing plugins for Gradle, it's a recommended thing to change the dash bin classifier to dash all, because that will also download sources, so you can do better debugging and follow through the API in case that you need to know what's going on with the Gradle API. One more reminder, whenever you have any questions, please let Roberto know, and we'll figure out how to answer it as soon as possible.
Definitely.
So the next one, yeah. There was a comment over there?
No, just saying that I'm looking into the Hangout, okay. And if there is something, I'll let you know.
Okay, thank you, Roberto. So the next one is invoking Gradle anywhere on your project, and this is related to the Gradle wrapper. Because now, let's go into another project. I often use the Griffon build as my workforce for all these samples. Now, the Griffon build is a project that contains around 48 sub-projects and has a wider range of structure. So I can say, for example, I go into the Griffon core project, and then I know that I'm 2 levels up, and there's 2 levels deep inside my hierarchy. So if I want to use the Gradle wrapper, I now have to invoke it in this way. Gradle W, and then do, I don't know, something like Griffon core or clean. And hopefully I met the project is in a working state, and it's invoking the build. The problem with this thing is that I now have to remember at which location I am at right now in the structure, so that I can go as many levels up in order to locate the Gradle wrapper. If my hierarchy, it's more complicated than just 2 levels. In the case of Griffon, it's always 2 levels. Then you will get in trouble. So what if there was a way for you to invoke the Gradle wrapper anywhere within your build, even including the, let's go, I did clean, even including your sources, for example. Let's go into source, main, Java, and one of these things like this, I believe. Here we have some sources. What if I'm editing something quickly here with VI, which by the way is the best editor, and then I want to compile immediately. I will do everything in the command line. Well, now I'm so many deep levels inside that I will have to issue a lot of codes like this, and I might get in trouble trying to remember where am I? No, it's not yet there. So 2 more levels. No, not there yet. Here we go. See, not really that useful. So what if there was a way to invoke your Gradle build as easy as possible? Well, there's one project called GW. I already have an alias for this called GW. And I can say now, Griffon core classes, and this will compile this project. Even if I'm inside the sources, it doesn't matter where I am in my project, it will locate the build file. Oh, I expected there's some compilation errors. I was working with this project, but you can see when you invoke GW here at the top, these lines are the important ones. It says that it found Gradle W at this location, which is the root of my project, and it found this root file here, the build.gradle, which is the one that I want. How do you get GDOP installed on your project? Well, it's as easy as this. You go to this URL, clone the repository. I believe there's also possible to install it if you're using OS X and Homebrew. And once you have it, then GW will attempt to resolve the wrapper first. If you have it in your project, then it will work. If you don't have it, then it will try to resolve your local version of Gradle. If it resolves successfully, then you will be able to build, and if it matches the version. But if you do not, then of course the build cannot proceed. Now there's no other magic that GDOP can do. This is just a simple script in order to locate the wrapper anywhere in your project. Okay, the next one is the multi-project setup.
I have a question for you,
Yes.
Andres. Yeah, so this is coming from Jorge, and he's asking, does Gradle build require Groovy? And if so, this can break the build process more often than Maven?
Requires Groovy, yes, in the sense that the build file is defined using the Groovy syntax as a DSL. It does not require Groovy as a dependency on your project itself. It's a dependency on the build itself. Now, there's the possibility to use Kotlin as a DSL also. You still will be using Groovy as a dependency in the background. Why? Because at least the 20% of the Gradle tool is built using Groovy. It's something that people think that Gradle is strictly tied to Groovy and that the implementation is mostly Groovy, but it's not. It's actually mostly Java. And I wouldn't say exactly that relying on Groovy will break your build, because, well, we've been building Gradle projects for more than 7 years, and we haven't had really much trouble just because of the chosen language for DSL. But just in case, you can also use Kotlin, and if anybody wants to, they can also build an XML-based DSL or any other kind of a scripting language if you really, really want to, on top of the Java-based tooling for Gradle. But nobody has done it so far.
Okay, thank you.
All right. So let's get into the next one, which is the multi-project setup. And I believe this is the killer feature why Gradle, it's most of the times works better than Maven. And it's a little bit of a problem when you have a lot of build files that have the same name. And this is the same thing that happens in Maven. You have all the build files have to have the name pom.xml. And then using an IDE such as IntelliJ, then when you open one of these POM files, the tab of that particular editor will reflect the name of the project. So that's excellent. That's great. But if you're editing your files in a simple text editor such as BI or TextMate, then the name of the file will remain the same. And you may find yourself in a position where you're editing the wrong POM file or the wrong build file. So Gradle gives you the capability to rename the build file to something else. My proposal is to use the name of the project. So, for example, if I have a project called Griffon-core, then its build file, instead of build.gradle, will be griffon-core.gradle. So that's one thing that you can do, but you still have to tell the project that you changed the convention. And you do that in settings of Gradle. So I'm going to show what the 2 steps that you need to do now since Gradle 4.2, because there was a change in how you define the inclusion of your paths if you have special characters. So the first thing you do in settings of Gradle, remember that this is a GUI-based DSL. We define a closure, or if you're more used to this, this will be similar to a lambda expression in plain Java. Takes 2 arguments to string the name of the project, the directory of the project, or the name of the project. And we're doing here is just creating a few files. See, this is nothing very different from Java. If you're used to Gradle, we just don't have any semicolons. We have value interpolations, like any other languages. So here we calculate the name of the file, and now we make use of these variables to figure out if we are in the right place. So it's a great thing, given that this is GUI-based DSL, we can have access to regular assertions. So we check that this directory exists and that this file exists. If that is the case, we'll simply include the project, and we change some properties for that particular project. So we're making sure that everything aligns correctly. So the next thing that we do is actually include those projects. Say, for example, you have the following structure. You have a common and full and light subdirectories, and inside each one of these directories, you have your actual projects. So with this code, we're just iterating over all these subprojects. We are trying to find if there's a match for that particular Gradle file. And if it is, then we simply include it. Notice how we're just including the name here. This is the name of the directory. And this is the name of the subproject that we want to include. Perhaps the variable names are not so clear, but should be changed. But that's exactly what is going on. What's the great thing about this is that you want to include a new module, simply add a new directory in the right location, any of these three, or any names that you may have in your own custom conventions. And make sure that the subdirectory that you add has matching Gradle file, and there you go. If you want to remove that Gradle file or that module from your subproject, just simply rename the directory or take it out. There's no need to change the build settings anymore. In the Maven world, you will have to add or remove a module entry in your root POM. Well, the next one is, and this is a question, this is something related to the question from Jorge, is if I'm using a Groovy-based DSL, and I can use Groovy, which is a full-blown programmatic language, then I might get in trouble because I can write anything I want to, right? So let me tell you what the Gradle build file should not be. It is not the works of Shakespeare. It is not War and Peace by Leo Tolstoy. It is not the credits of Gone with the Wind. What you really want is your build files to be as small as possible. My recommendation is that your build files should describe how your project deviates from the conventions. If you see yourself specifying conventions over and over again, then there might be something strange going on with your build file. So one thing that we can do is definitely embrace the power of conventions. Gradle follows the same conventions as Maven. So if you're building a Java project, then sources should be under source main Java and source main resources, and your test sources should be under source test Java and source test resources. There's nothing that you need to specify if you don't have those directories. If you want to have different conventions, just like in Maven, you will have to specify them out in build file. If possible, rely on secondary scripts segregated by responsibilities. For example, in many of my projects, I put everything that is related to code coverage into a secondary script and then just include it whenever it's needed. Everything that has to do with code quality, for example, checking the licenses or applying PMD on check style, also goes into a secondary script so that I can include it whenever it's needed for any particular project. You can define tasks anywhere at any time. You can put it on your root build file if you want to, but I would recommend them to put them in separate files. You can put it in secondary scripts. You can have regular task definitions, which are one-off tasks, or you can define plugins also inside these secondary scripts. But once you are starting to get into the world of writing plugins, you may want to put them into a special directory at the root, which is called build source. This is a secondary Gradle project that is always executed before your root project. This allows you to create tasks and plugins and set up additional features that are required by the build. And once you have figured out that you want to exchange or share this new behavior with different projects, then the recommendation is to create an actual plugin project, which is just like any other regular Gradle project. You just simply push the artifacts to a repository, and then you can consume it directly for any other project, just like any other regular dependency. You can apply plugins using two modes. You can use the plugin block, which is the most recent syntax since Gradle 2.1, or you can use the build script block, which is the one that is available since I think is something around Gradle 0.7. I personally prefer the old school way because it allows you to define exactly where and when you want to apply the plugins, even in secondary scripts. A problem with the plugins block is that it has to be the first block that you define in your build file, and it cannot be applied on a secondary build script. Next one is don't reinvent the wheel, apply plugins instead. And your first step will be to go into plugins.gradle.org. This is the official plugin portal from Gradle. You will find lots and lots of plugins here. The portal is actually, the usability is not that good, I have to say, because there's only a simple search input field here. If you type version there, you will get a list of every single plugin, because all of them have version somewhere in the description. So you have to be aware of exactly what kind of tags you put there. But once you find a plugin, you click on the link, and it will tell you how you want to install it, and most likely there's going to be a link to the documentation stating how you can actually use the plugin. There are other plugins that are not listed in this repository, so a little bit of Googling will allow you to find any other capabilities available to you. Here are a couple of plugins that I use pretty much in all of my projects. The first one allows you to compute a report of dependencies to see if one of them is out of date or not. So I have it already installed on this project. We're still in the source, you remember. So now I can call using gdop. Like I say, Griffon core dependency updates. This is a task added by the versions plugin. This will tell me how are the dependencies for this particular subproject. I will expect all these dependencies to be up to date, and we'll see in a moment. So now it's downloading metadata. Excellent. So all these dependencies are up to date. This dependency is actually a build dependency, but versions will tell you both build dependencies and project dependencies. There's a new version of Mockito, so I should upgrade. And it was not able to find metadata for these particular dependencies. These can happen sometime, depending on how these artifacts were published to the repositories that were queried. So this returns with a simple report. Now, manually, I can decide if I want to update, for example, Mockito Core to the latest version, or just leave it with 2.10. It's up to you now to decide if you want to update or not. The next one is the license plugin. The license plugin has two features. One of them is that it allows you to format the file headers with a particular header. This will keep track, and you can add some variables if you want to. So, for example, if you want to automatically update the year or the author or the name of the project, that's very, very easy. But the other thing is that it allows you to download a report of all the licenses used by your project, all the compile time and runtime dependencies. So if I do the same thing here with the Griffon Core project, I can say download licenses, but like this. But I know that it's also another great feature by Gradle, which is specify the least amount of characters for a particular task. So I can say something like download license or DL. And this invokes the download licenses task. And it was not able to find the POM file for this one because this dependency has not been published. This, as I said, I was mucking around with this particular project, so I can do something quickly. Stash, and change to a different branch. I know this should work, and then invoke it again. And this should be able to resolve all the dependencies for this particular version. There we go. So now I can open the reports. We will have to go up again where we are in source. There we go. Open, build, reports, license, and let's open the dependency license HTML. Safari kicks in, and here we go. I only have 3 dependencies on runtime that I care about. And you can tell there was the name of the dependency, the jar, the particular license, and a link to the license agreement. You also got this report on an XML, so you can further post-process this and give your customer a quick summary. Because some customers probably will ask you to not have GPL-based dependencies because of the viral nature of the GPL license. With this, you can assert very simple and very quickly if you have a license that your customer may or may not be happy with. Finally, versioning. Versioning gives you access to SCM system. So if you want to know what is the latest hash for a Git commit, or the message for the Git, or the author, or CVS, or SVN, then just apply the versioning plugin, and then you can have it directly. We'll see in a moment how we can make use of this thing. You can also, with the versions plugin, you can filter versions. This particular snippet of code is taken directly from the documentation of the plugin. What this piece of code is telling you is that if any of your dependencies happen to have the classifier alpha, beta, or RC, it will be excluded from this version selection. So in this way, you'll be able to tell that versions will suggest you to update to the latest stable version because it will not be tagged as alpha, beta, or RC. Next one is keep all versions in one place. And what I suggest is to put them, everything that is declarative should be, in my humble opinion, inside the Gradle.properties file instead of a build file, because this is a simple text file. And here I have a list of different versions and for all my dependencies. And they will be available in your build file regular variables. So there will be a variable whose name is a utility version, another will be Yukito version, a watermark version, and so on and so on. So once you have these versions in one place, you can use them anywhere where they are needed. For example, in your build file, you can define your dependencies in this way. If you need to use the React effects dependency in different locations, then just define that particular line, just like that, whenever it's needed. So once you have decided that you need to update to the next version, you just have to go back to Gradle.properties, locate the definition of the React affairs version, say, oh, then let's go into version 3.0 because that happens to be the latest one. You just change it in one place, and now your whole project will be updated. One project that problem that can happen, and happens quite often, is that because you are consuming dependencies that can have different transitive dependencies, you may have the same dependency name with two different versions. And we have to ensure that we are using the same versions in order to avoid class path problems. So one way that you can do this is with this particular piece of code. You typically put this at the end of your build file. Once you have resolved all configurations, we force for the resolution strategy the following versions for these dependencies. And here is another great usage of the same version that we define in Gradle properties. So what we're seeing here is, for example, we're fixing the version of SLF4J API to whatever version we had in Gradle properties. I believe we set it to 1.7.25, which is the latest one. And now the secret sauce is actually the last line we see there, resolution strategy, fail on version conflict. Now, when you attempt to execute your build, if you happen to be consuming two different versions of SLF4J API that are not compatible with one another, and if you were not to have a force here, then the resolution strategy, fail on error or version conflict, will tell you there is one version of SLF4J, say, for example, 1.7.21 on one place, and 1.7.25 on the other place, and that should not happen. So that's why we are having the force. If there is another version, for example, Guava, which is very common, some tools use Guava 19, some others use Guava 23, and because we didn't have any force, the moment that you try to make your build, it will tell you there is a conflict, and you now have to solve it. You can solve it using a force, or you can find the offending project, if you will, and mark an explicit exclusion on the Guava dependency, and there you go. You can supply more information to developers. This is something that I also like to do in a lot of projects. And quickly, if we go back into the sample project that we created before, and when we run it, I'm going to run it using the GDub. So I will run using the right wrapper and the right versions. It will pop up the window, but it will see in the log statements in just a moment. There we go. It says that it's version Griffon 2.12. It was built at this time, but it also was built with this revision. This is the last Git hash commit for that particular release when it was posted. Now, where is this information coming from? This information is encoded in the manifest. And we're going to use the versioning plugin to find that information. So once you have all the metadata that you want to add to the manifest, you simply add it like this. And there is the build revision tag that we added. Yes, it's accessing the versioning plugin, just like that. Okay, you can have incremental builds, and this is great when you have, let's see, you can invoke the incremental build using -t. So let's see that in action. Let's go back into the command line. I believe I have this file open. Yes. Okay. So I'm going to do the following. Sorry for jumping so much. I'm going to do GWT classes. And that compiles the project and leaves the build running in the background. So now I'm going to make a change here. I'm going to change something like a system.out in my controller. So I'm going to put this here. Put a print line here, system out, print line, live from vJUG24. And I'm going to type save, and you will see what happens in the command line. Detected a change, it executed the build, and goes to sleep again, waiting for a new thing. So I can do many things here, do a save, and it will kickstart again. So what this -t is doing is listening to changes to observe the resources. Which resources? The ones that we specified here. We did not specify any resources explicitly, but those are the resources watched by the classes task, which will be the sources for source.me Java and resources. So in this way, you keep the build running, and it gives you a very, very quick feedback loop. You can aggregate code coverage reports. I would suggest you to use Jacoco. If you are not using a code coverage tool already, or using Cobertura, Jacoco gives you much, much better results. And Jacoco only works for a simple project, but you want to be working for a multi-project, you will eventually have to merge and create a single report. So here's one way that you can do it. You can define some variables in your root file. So this is the way that you can define additional variables in your build file. We're going to make use of these values later, but the important thing is this list at the beginning, projects with coverage. We're going to add projects to this list as we go. So for every project that you want to cover, you will apply this code. This code will typically be in its own secondary script. Remember what I was telling you about before, putting everything related to coverage in one script? Well, this is exactly the whole contents of that secondary script. And the last line is the important one. When we append or we add the project to the list of projects that we want to track, and then we go back into the root project at the end of the build file, and we put this code. The line that you see there, evaluation depends on children, is very, very important. We have to give a chance to every sub-project to be able to configure itself. That means to apply the code coverage before the root project can do the following task, which is define the root merge of every single Jacoco execution data. So we give it a type. We use the nice feature from Groovy, which is the GPath expression, so a list that invokes the test property on every element. So we get a list of all the test tasks and a list of all Jacoco test reports with a simple command like this. And we do the same thing with execution data. We make use of one of the variables that we defined earlier. And then we actually generate a report that depends on the task that we defined before. It's of the right type. We make use of GPath expressions again to find all the sources that need to be added to these properties, and off we go. This is all that you need to do. There's nothing else.
Sorry, Andres, you have 5 minutes left?
Yeah, I'm almost done. Mind the target Java version. Thank you, Roberto. And this is, wow, now that JDK 9 is released and coming up with the next versions in the next year, that will be a little bit of a headache. So this will be very, very important. If you're building Java and Groovy projects together, you have to explicitly define the source compatibility and the target compatibility. If you do not, then the Groovy will use the whatever version of the JDK you're actually running, say, for example, JDK 8 or JDK 9. But if you want to target JDK 7, then your bytecode will still be 9. So make sure that you make use of explicit definitions. If Javadoc is too pedantic for you since JDK 8, you can tell it to be quiet just by adding this particular snippet of code. And if you want to, you can activate the compiler warnings using this snippet of code. And the lint value here, this name is something that you define. I decided to choose lint. And you can activate it in this way, lint equals true. And because this is a string in your command, make sure that if you're expecting a Boolean, you transform it to a Boolean. Otherwise, if I just simply say root project.lint, this will be evaluated using the Groovy truth, and a string, even if it contains the contents of false, will still be evaluated to null, to true, because it's not empty. So if you expect something that is Boolean, make sure that you transform it to a Boolean. Okay, finally, if you want to get ready for JDK 9, make sure that your project builds correctly with JDK 9. And there's a tool called JDEPS, and there's a Gradle plugin called JDEPS, which will run the JDEPS command against your production sources, but also against your dependencies. Because it's not enough for your project to be JDK 9 compatible, but also your dependencies. So I'm looking at you, vJUG24 is not compatible with JDK 9 completely because it makes use of some misc unsafe in 14 different places. So this is one thing that the JDEPS plugin will tell you, where your dependencies may or may not be compatible. And finally, there's a huge list of plugins that I can suggest you. We already saw licensed versions and versioning somewhere else. But if you want to write a documentation, I would certainly recommend you the first step will be ASCII Doctor, JBake, or Markdown. If you want to consume artifacts coming from an Apache, from Sonatype Nexus, then it's the next plugin. There's also Bintray and a few others. Here's another set of lists. We got the versioning plugin as before. You can do mutating testing with PyTest. You can do database migrations with Flyway. If you want to have the bill of materials support that Maven has, or BOM files, if you will, then apply the dependency management plugin that you see there. And let me remind you, everything that we saw today is open source. The easiest way for you to contribute to open source is that if you find a problem with anything that we saw today or any other project that you see out there, please file a ticket. There's no need for you to supply a patch or a test case. If you have the time, the inclination, and the passion, please do so. But at the very least, if you find a problem, please file a ticket. Believe me, that is plenty of help. So with that, and if you want to find out more about what we saw today, I have a newsletter coming up. The first link is in English. The second link is in Spanish, exactly the same content. So feel free to subscribe. And if you find any errors or you want to discuss a specific topic, please let me know. And with that, thank you very much for your time. I believe we still got like 3 or 4 minutes for questions if you have them.
Yeah, we do. Yeah, Andres, thank you so much for this awesome presentation. I'm pretty sure that's going to be very useful for people that are using Gradle at this time and people that are moving from Maven to Gradle or something similar. Regarding a couple of questions, so picking up the last couple of topics that we were discussing about JDK 9, we have a question here from Bruce. He's saying, how well does Gradle support building JDK 9 modules and multi-release jar files?
Okay, so Gradle builds with JDK 9. Gradle runs with JDK 9. You can target, you can build projects that are targeting JDK 9. There is actually a couple of posts posted by the people behind the Gradle tool recently on how you can build with JDK 9. There is a guide, but building multi-resource jars is not as easy. I'm afraid there is no build tool right now that can give you a sound solution. I do have a working project with multi-resource jars, and this is thanks to some hints that the Gradle people, in this case, Cedric Champeau and Eric Wendelin, posted. You will find these links in the Gradle JDK9 guide, how you can actually run and build multi-resource jars. The problem that I have found so far is that you can compile and package within the same subproject or within the same project, but I had trouble running the test cases because you will have to have two different JVMs running at some point, whereas compiling is not too much of a problem. And again, please refer to the official JDK9 from Gradle in order to find out how to make this. It's not that difficult, but it's something manual that you have to write. And there may be, I think there's a Jigsaw incubating plugin also from Gradle that will give you the capabilities to build modular applications.
Awesome. Yeah, I think there is no more questions, or at least no short ones, apparently, to Simon. Maybe Simon Verhoeven here has like a couple of more complicated questions for you, but you're on our Slack channel, so you can have a chat with him and see what his troubles are.
Yeah, definitely. I will follow up on Slack.
Yeah, so we're going to wrap this up. Thank you so much for joining us, Andres. Really nice to see you here again on the vJUG, and hope that we can see you again in the future somewhere.
Okay, yeah, thank you very much again, Roberto, for your time, and everybody of the attendees, thank you very much for your time. Everybody else watching this stream later, well, thank you also, and feel free to contact me at on Twitter or Slack on my website in case that you want to have a different follow-up.